All right. So this is a talk on uh, how do we transcode to G.711 in GSM networks if we need to do it, and for context, how does it help match the quality of commercial networks? So, all right. So I actually revised this slide as I was preparing it. This part in parentheses I added in a last-minute revision after I had watched the presentation from OsmoDevCall by Michael from AMN, which was quite interesting. Very emphatically saying that open source free software mobile networks are real mobile networks. Well, yes, great, but I'm kind of in a different geopolitical context here, and so the observations that I made, and these observations were made even before I got into operating my own GSM network, back when I was just playing with the mobile side of GSM, is this is the chain of fallback that is implemented. And I have personally tested this in the US. I personally tested it in Tijuana, Mexico. And as far as Russia, that's thanks to Vadim, because Russia is unfortunately a country where I am no longer welcome. But Vadim is there, and he did some tests about like fall of last year or something, and found out experimentally that yes, they do have the same chain of fallback, to where they always give out AMR as first choice. So if your phone is new enough to support AMR, the network will give you AMR. However, if your phone is so old that it does not support AMR, or alternatively, if you have tinkered with the firmware on your phone and made it transmit a better capability information element to lie and say to the network, no, I don't support AMR, then you get EFR as your second choice fallback. And if your phone is so old that you don't support either one of those, then the network will fall back to FR1, which always has to be there. Every phone supports FR1, or at least every type approved supports FR1. So, and there is no provision in the spec. According to the spec, you cannot have a mobile station that does not support FR1. So that's your always last resort fallback. So this is the situation in USA. This is a situation in those parts of Mexico that are more first world like, and this is also the situation in the second world, thanks to Vadim. I was curious to see how this would be in AMN world, and I actually sent an email to Michael from AMN, but never heard a response. So that's still an open question. Just wonder how that happens there. But the takeaway for people who are operating their own networks using free open source software is, if your goal is to match the quality level of first and second world, Harold says that I would assume AMR on TCHH is the universal first choice. Well, yes, of course, there's no dispute there. That is the same way everywhere in the world. Here in the US, Mexico, Russia, they all have AMR and TCHH as first choice. But the question is, what happens if the phone does not support AMR? Will the network simply reject that phone? Sorry, we don't support that. Or will they fall back to EFR and then FR1? That's the big question. And I'll be particularly curious to know how AMN, for example, handles this, because they said in the presentation that they use Osmox, but Osmox only does AMR. So what would happen if someone connected a non-AMR capable phone? Open question. But at least for people who are trying to operate in the first or second world context, and who have it as the explicit goal to support old phones, like say if the whole reason why you operate in your own GSM network is to provide service to old phones, which the mainstream carriers will not support, then establishing an AMR only policy, that's just not interesting. At least to me, that's not interesting. I want to run a network that supports all phones. So that's one takeaway for free software. Another takeaway for free software is the DTXU. enabling DTX in the uplink. So DTX uplink versus downlink are very different, because in order to enable DTX in a downlink, you have to have a cell with multiple carriers, with more than one ARFCN. And, in the first, second world context, you're not going to be able to get that much spectrum. If you only have just a single ARFCN, you cannot do DTX downlink, but DTX uplink you can still do. And I personally consider DTX uplink very valuable, because you get battery savings in the mobile station. I don't know if that's still true or not, but in the past I heard a sentiment in Osmocom like, well, you should DTX, just turn DTX off. Well, if you turn DTX off, then suddenly you're not as good as the mainstream networks. So that's it for this slide. So now the transcoding. So again, this might be different in other geopolitical contexts, but at least in all the countries I'm familiar with, which again includes the USA, includes Canada, because they're also same technology as USA, and it also includes those parts of Mexico which are first world like, as well as, from what I can tell by remote experiments with Russia and Europe. In all of those places, you have to transcode to G.711 in your outside world interface, even if you're doing AMR. So in the past, I've heard objections, in the Osmocom community, how, well, the reason why other people are not facing the same problems that I'm facing is because everybody else other than me is using AMR. Okay, fine, great, you use AMR. But if you're making a call where on one end you have a GSM phone and AMR, or even a 3G phone and AMR, but on the other end it's a landline, or you're calling some, you're calling a bank, insurance company, whatever, and they have office VoIP systems. None of those things do AMR. So all of those calls will go through a transcoder at some point. At some point, they will transcode to GS711. The only question is this transcoding done by you, or is it done by someone else? So in other words, are you doing the transcoding yourself, or are you outsourcing it to your VoIP provider? That's really the question. And, when it comes to outsourcing transcoding, there is this saying, if you want something done right, do it yourself. Because if you outsource the transcoding, how do you really know if they're doing a good job of it? And for me, the practical consideration is, even not touching AMR for now, just focusing on FR1 and EFR. Here in the US, there are some VoIP providers that will support the GSM codec, which is just plain 06.10 without any of the DTX functions. And fine, okay, if I wanted to go down that path, I could do the DTX handler in my system and then transmit pure 06.10 to the outside world. But then it would only work with certain providers and not the one I'm using. The one I'm using, chosen for economic reasons, quality reasons, etc., does not offer GSM. They only offer G711 and G729. And of course, I'm not going to do 729, so I do G711. And then even if they did support GSM, 6.10, okay, fine, they support that. But if most of my calls are going to be EFR and not FR1, well, nobody supports EFR. So if I'm doing my own transcoder for EFR, might as well make it consistent and do both EFR and FR1, because EFR is the one that's so much more CPU intensive than FR1. So if you got the setup to do EFR transcoding, FR1 is peanuts in comparison. So that's where the G711 comes into the picture. And that's another interesting observation. I'm going to take a sip of water. With in both codecs, in both EFR and FR1, you have these optional in one case, mandatory in another case, feature in the spec, the in-band homing feature. It's a very neat feature, and I've tested, experimented, and yes, it does work, which is really nice. So in the case of EFR, it's mandatory. The spec says you have to have that feature in there. And so the way that works is, if you have a mobile station where you can play around with it using, your choice of FreeCalypso or SmartCom BB, you feed in GSM uplink, you feed your own crafted stream of frames. And if you include a special frame called the decoder homing frame, if you include a bunch of them in sequence, then on the other end of the link, on the output of the G.711 transcoder, you are going to get these octets. So in the US, we're using PCMU, you're going to get this. And in Europe and also Mexico also uses ALO, you're going to get this out of the transcoder. And yes, I have tested this feature on both T-Mobile USA and Telcel Mexico, and it works in both of them. And then the same thing goes in the opposite direction. So from the IP PSTN link, from SIP in G711, you can feed in long streams of these octets. And on the GSM air interface downlink, you're going to get a stream of decoder homing frames. So this has been tested and proven to work in both USA and Mexico on EFR, and also in USA on FR1. Haven't tested FR1 Mexico, haven't tested the combination yet. But the difference with FR1 is it's officially optional for the spec. And I think they put language in the spec that it's optional to save face, because when they first wrote the original FR1 spec back in like 89 or something for GSM phase 1, that feature wasn't there. They invented it later, and they retrofitted it. So it was mandatory for the other codecs from day one, but for FR1, they kind of retrofitted it and said it's optional. But now that I've made the observation that in both USA and Mexico, on the networks, on the commercial networks, this feature actually works. Well, that raises the point. Then, if a free software-based network omits that feature, then that free software network could be called deficient in comparison. And it's kind of you're like, well, what's the usefulness of this feature? Well, that means that the end user of GSM service can treat the transcoder as bit exact, because when you execute this homing operation, the internal state of the transcoder is reset to the spec-defined home state. And from that point onward, the operation of the speech transcoder in both directions is bit exact per the spec. And so essentially this bit exact capability is now exposed to the end user of GSM service. So if the end user wants to play around with bit exact transcoding, they can. And I like to preserve this feature in the free software replication of this stuff. Let's see what we've got. All right, so the libraries. Because if you're going to implement a transcoder of any kind, well, you have to have libraries to implement the codecs that you're after. That's like the very first requirement. So what was the state of codec libraries before I threw my hat in the ring, before I entered the picture? So, well, the slide, that's what it was prior to me joining. And it wasn't all that great. So for FR1, you've got libgsm, but there is no support for SID. So you can't do DTX and uplink. So if you want to enable DTX and uplink, well, then you have to write additional code to implement all of the rules of GSM 06.31, GSM 06.11, which is the ECU, plus GSM 06.12, which is the comfort noise generator. So you have to implement all of those things, which are not that difficult, but still, it wasn't pre-existing, so I had to implement that. That was the first thing I did. Then also another problem with libgsm, the classic libgsm, it goes back to the 90s, is the API exported by the library does not provide a state reset function. So of course the transcoder is stateful. Every complex codec is a stateful entity. So you have a stateful encoder engine and you have a stateful decoder engine, and you have a GSM_create function that will create and give you an opaque codec state object, and then you pass this pointer to your encoder and decoder functions, and they have the same state structure is the same in both directions. But there is no function exported in a library API that will allow you to reset the state. So say you have the existing context, you've been running the session for a while, then I want to say, no, reset it. Reset this to home state. There is no function that will do it. I mean, you can dig inside the structure, break in the abstraction, but then you have to include private headers which are not otherwise available. It's there's really no practically viable way to do it that would be in any way clean. So in the latest version of my Themyscira Wireless GSM codec libraries package, I actually stopped using libgsm as an external dependency, and I just incorporated the code. I mean, the code, libgsm was thankfully under a very, very free license. So other people have also done similar. Like I know, what is it? What's the name of that library? SpanDSP. Yeah, SpanDSP that also has the functions for modem emulation, fax modem, and whatnot. They also have their own copy, fork, whatever you want to call it, of libgsm that they just integrate, ported over. So I did the same thing. I took the code from libgsm, I ported it over in my own environment, cleaned it up, polished up the C dialect, and of course, added the reset function, because the reset function is what you need in order to implement this homing feature, which I just talked about. So that's what but that's FR1. Now with AMR, with EFR, the problem is even harder. Okay, I said AMR also. AMR I haven't got to. At some point, I will maybe later play with AMR, but right now it's like a very, very low priority for me. But when I do eventually get to playing with AMR, there I will also have issues like with the reset functions, because AMR also has, by the spec, it also has in-band codec homing frames, and the problem with the open core AMR library is it's not there. The API does not export the state reset function. Same problem as with the GSM. And again, they have this shared library, and the internal function is not exposed. It's kind of like similar to how some of the libraries in SmartCom now, they use this map file where they list what symbols are going to be exported, and the other internal symbols are not exported from the shared library at all, so you can't even link to them. It's the same problem here. So if the reset function is not exported as part of the official API, there's nothing you can do as far as digging under the hood to get to it, unless you're willing to just fork the source, take the source for the original library and rename it to something else and modify it. But if you want to use libopencore AMR, libopencore AMR NB, if you want to use this library to implement EFR, which some people have done, well, that's also really limiting, because you cannot do seed frames. So people say, well, EFR, GSM EFR is the same thing as the highest 12K2 mode of AMR. Well, yes and no. They are similar enough to be compatible for speech frames, but the way you do seed frames, silent detection, is completely different. Just not just frame format, but the entire paradigmatic approach to how it's done is different. So it wouldn't be possible to use libopencore AMR and B to implement EFR with DTXU enabled. And again, I want to keep DTXU enabled because I don't want to be worse than the commercial networks in this regard. So that was the pre-existing state. And let's see, what are the issues we have? Yeah, now this issue is not directly related to transcoding itself, but it kind of goes along with it. So when you start putting the whole thing together, where if you're a network architect and you're putting together your complete system, so you have your SmartCom CNI software suite, and then you have your additional software, whatever extra software you have beyond the SmartCom that's going to do the rest of the job, that's going to interface to IPPSTN and do transcoding and do all of those things. When you put this whole system together, where is your interface point? Where do the two meet? Where does a SmartCom and outside world meet? So it seems like the official answer in SmartCom has always been the Osmo SIP connector. And so now you have this internal SIP leg, which does not go to the outside world. That's just between Osmo SIP connector and whatever PBX or other software you use. But when I was looking into it early on, I immediately found that I used this word, that it's a straitjacket. Because it really feels like a straitjacket. It's very constraining, having to go through this interface, this bottleneck. So I mean, here I'm not going to read, but you can read why, it's such a problem. And especially as an exercise in thought, try passing a CSD call through there. I guess the CSD call, you have all this metadata and better capabilities. Is it transparent or non-transparent CSD? And are you trying to go to V110 or V120 or NLEG modem emulation? You have all this metadata there. How in the world are you going to pass that through SIP? I mean, I'm sure if you work really hard, you might come up with a way, but it just feels like, hammering a square peg into a round hole. That was my dislike of this paradigm. And then there's also the problem with DTMF, because in GSM, the user has the ability to generate DTMF tones of arbitrary duration, arbitrarily short or arbitrarily long, because with every phone that I've tested experimentally, when you are in a call and you press one of the DTMF buttons with your finger, the moment you press that button, they transmit a start DTMF message. And when you lift the finger from the button, that's when the stop. Now, keep in mind, of course, that's used on phones with physical buttons. I guess a lot of people these days use those touchscreen phones, but I've never used a touchscreen phone in my life and never will. So I don't know how it translates to that world. So maybe in that world, the paradigm doesn't apply. And so people haven't thought about it. But at least with real phones and real keypad buttons, you press the button, you get a start DTMF message, and you lift the finger, and that's when you get the stop DTMF message. And so up front, when the start DTMF message is generated, and when the MSC receives that message, you have no way of knowing how long that button will be pressed. But that doesn't play with the SIP paradigm, the Osmo SIP connector, because Osmo SIP connector, as soon as it receives the start DTMF message, it immediately does the info method on the SIP lag. And in that info method, you have to give the DTMF duration up front. And it just uses some kind of hard-coded constant duration there. And this is not a problem that can be fixed with a Garrett patch. This is a fundamental architectural problem. And the problem is not even so much the SIP connector itself. It's not the code of SIP connector that's at fault. It's the paradigm, the very architectural choice of using this internal SIP lag as your interface point between OsmoCom and non-OsmoCom software. So that's where the real problem is, in my opinion. Yeah. Now, this slide I added as part of my sort of last-minute revisions after I watched the videos from OsmoDevCon. So in OsmoDevCon, there was a very nice presentation by Niels. Thank you, Niels, for your good presentation. Covered in extensive detail all of the problems with AMR and mode sets and everything, which I know builds on top of your previous talks that were given here on OsmoDevCall. But as I think about it, then I realize where the paradigmatic difference is. And in the past, people have told me, well, Mychaela, the reason why you are not facing all the same problems that we are facing is because you don't use AMR, and we do use AMR. But that actually not is the real reason. Because even if I did use AMR, or actually, let's change that if to when. Because in the future, I fully expect that someday I'll probably add AMR support. Of course, it'll be an option. It'll be optional only for those phones and only those users who wish to use it, with the older codecs still being supported. But the option will eventually be there. But even when you use AMR, it's still the paradigm stays the same. Because if the outside world is G711, if your outside world direction is always G711, then on the inside of the network, you can do whatever you want. So all of the issues with, I know like Niels in his previous work gave so much attention, so much work has been put into the topic of what if the two legs have different ideas about what payload type number should be used because they're dynamic payloads. You can use for AMR or EFR. You can hypothetically use any number you want from 96 to 120 something. So how do you reconcile those differences in payload type numbers? And how do you reconcile the difference between bandwidth efficient versus octet-aligned AMR? And what about all the representing different AMR mode sets? So much work has been put into all of this. And I'm sitting here thinking, well, why is all this work needed? Because if the outside world only speaks G.711, and whatever you're doing on the inside, be it AMR or not, you have to transcode in your transcoder to G.711. That's your bridge. That's your sentinel between the inside world and the outside world. Well, then on the inside, you just do whatever is the easiest thing to implement. Use fixed payload type numbers. Decide up front what you're going to use for mode set and octet aligned, and just be done with it. So this is a real paradigmatic difference. So, but a reason maybe other people have different experiences. Maybe in other parts of the world, which, okay, well, I don't know which number the world it would be. Where in the world can you get the outside interconnection that's not G.711, where the outside world actually speaks AMR and everything else? That must be a different world that people live in where they have these issues. Yeah, don't really know. But this is sort of the clash of two paradigms here. So let's see where we go from here. So this is the solution. This is what I'm doing currently. Well, okay, what I'm doing currently is just this. So I'm still using this elderly version of Osmo MSC. So I now run a kind of a hybrid stack to where I've updated all of the OsmoCom libraries and all the other components like Osmo BTS, Osmo BSC, Osmo MGW. I've updated all of those to current master, but Osmo MSC, I'm still running this elderly release because, I just didn't want to get into the new style of Osmo MSC with SDP and MNCC. Just didn't want to enter that world. Right now, this old pre-SDP version of MNCC, that's currently my interface between Osmocom and Themyscira. And this is what I'm working on currently. So from this point onward, like from here onward, all of this is work in progress. None of this has been implemented yet. So this is all just, thoughts. So I'm thinking I may have to fork Osmo MSC and have my own Osmo MSC derivative, but then still keep mainline Osmocom for everything else. So, this is not, I'm not trying to fork all of Osmocom. I'm trying to keep as much mainline Osmocom as possible. So all of this will still be mainline. But like I said, even the partial fork is still bad. Okay, so why? Why am I trying to do this? Yeah. So the two ASCII art diagrams here should hopefully illustrate what my dilemma is. So the dilemma I'm facing is right now I got this. Yeah. So this extra hop through Osmo MGW, well, I mean, this is a user space component. It's taking up UDP ports okay. So the new MNCC should be backward compatible. Should be in theory. There may have been other changes that may have been unintentional, accidental, that changed the behavior. One behavioral change that I did notice with the new Osmo MSC when I had the limited supply of spoons to try it, and when I would generate the mobile terminated call with the old MSC, that I'm using, in the setup message in the MT direction, there is no bearer capabilities IE, which I believe is correct. So my interpretation of the 3GPP spec, what is it, of 24.08, used to be just a 408. So my reading of the spec is that in the mobile terminated direction, from the network to the mobile, in this direction, in the setup message, you should be sending bearer capability only if it's a data call. If it's a speech call, then the bearer capabilities, i.e., should be omitted altogether in this direction. And only when the mobile responds with call confirm, then the mobile sends bearer capability indicating what codecs it supports. So the very concept of the network sending upfront bearer capability with codecs indicated in the network to mobile direction, to me, that seems wrong. That seems like it goes against the spec. And in theory, the mobile station should just ignore that superfluous bearer capabilities, i.e., and send out its own. But in practice, in my experimentation, a lot of mobiles behave weirdly. So, in my experimentation, when the mobile station receives this second valid bearer capability, i.e., from the MT setup message, then in the response and call confirm, I don't remember exactly what it does. Either it completely omits the bearer cap IE or it omits the codec list, or it does something weird. I don't remember. But I didn't really like that change. Was not happy about that change at all. And then I ran out of time. I ran out of how much time I could spend on this. So I kind of shelved it and went back to 2023 February version of Osmo MSC. But this other problem still remains, that even with the old version of Osmo MSC and old version, new version, this will be the same, this aspect. I still have this extra hop through Osmo MGW at the MSC site, which feels superfluous to me because I have to have this other entity here anyway. So this little baby here, this MYMGW, that's where the transcoding happens. That's the transcoding MGW, which I am actually in the process of rewriting. I have my first version, but I'm now writing the new one, which will have the retiming and other complications added, just from practical experience, because I've been running with the old version for quite a while now, and operational experience has shown where improvement is needed. So now I'm writing the second version of it. So with this thing needed in any case, why do we want this extra guy? So what I really want is this kind of simplification, but I don't know how it seems inconceivable to me how this could be merged ever in the mainline Osmo MSC, not to mention that I'd be completely ripping out everything that to do with 3G, because yeah, in my case, there is no possible need for 3G. You know, when you're doing first world retro networking, when the whole reason why you're building a new network is to replace the services that have been shut down and taken away by the major carriers, and you're operating in teensy tiny slivers of the spectrum, nobody is going to give me 5 megahertz of spectrum to run 3G. So 3G is just basically off the table completely. So it's a 2G only network. So that's kind of, but everything here that's on this slide, this is still wish list territory. None of this has been implemented yet. This is just me thinking, further down the line what I would like to do. But of course, there are downsides. The opening paragraph on this slide, that is very true. Having to do my own fork of Osmo MSC would be highly unpleasant, both technically and socially, because I want to be a part of this community. I like being part of this community, and forking is just the wrong thing to do, even if it's just one little component. So when we get to discussion phase, I'll be very open to alternative ideas, but this is my current thinking out loud, what I would like to do going forward. So let's see, what do we have here? All right, so this is the alternative I was thinking about. So what possible thinking out loud alternative approach might be more friendly to Osmocom community and be more synergistic with the sort of Osmocom way of doing things? So would it be possible to take the function of transcoding to G711 and integrate it inside Osmo MGW? And then all this paradigm that Niels pioneered with SDP and MNCC, what if we could tell on the SDP MNCC leg, if we could indicate G711, have that passed down to OsmoMGW at the MSC site, and have OsmoMGW do the transcoding. Well, aside from the obvious fact that it would be 1,000 times easier to write a new program from scratch than to integrate this into OsmoMGW and get it, to the right coding standards and do it without breaking everything and pass code reviews and pass everything. Aside from that difficulty, the other difficulty with this approach is, well, what are we going to do about codec libraries? So especially this bullet point right here. So while I take a sip of water, look at that highlighted bullet point, is particularly for the EFR codec. I mean, for the other codecs, all right, for FR1, the improvements that I did, on top of libgsm, that's my own original work, so there are no copyright issues there. AMR, I haven't even got to AMR yet. Half rate, HR1, I don't think anybody cares about that. But EFR, this for me, EFR is the one I really care about. And my implementation, I have this package, it's a GSM codec libraries and utilities package, the Mychaela Wireless. It's public, I can download it, play with it. But the EFR library is derived from the original code by ETSI. And, of course, INL and all of those disclaimers, but I've heard at least the sentiment, the prevailing dominant belief in open source community is people in FLOSS are unwilling to use that code in the form of as is reuse because they say, well, it's copyrighted by the ETSI and it was released under a very, very non-permissive license and you can't do it, etc., etc., etc. So now, another point for people to consider is AMR is not fundamentally different. To the best of my knowledge, no one has done a from-scratch reimplementation. So I know, like, the general sentiment in OsmoCom and other similar open source communities is if the existing source is under a non-free license or no license at all or stolen, whatever, and you can't just directly reuse it, well, then the answer is to just re-implement it from scratch, like OsmoCom BB and so many others have done. But to the best of my knowledge, no one has done this with any of the codec libraries, not even with AMR. AMR, that's like the most popular codec, the one everybody wants to use. But the open core AMR library, it is not a from-scratch reimplementation. It is a derivative work in the strictest sense of this term. It's a derivative work based on the original source of 3GPP. Now, it's an indirect derivative work. It's kind of like a long chain of derivation. From what I could tell, it was the Packet Video folks. Packet Video folks, they were a company playing in the Android ecosystem. They took the original code from 3GPP and they did whatever they did as far as legal maneuvering. They talked to, it must have been even more difficult for them because it was 3GPP and not ETSI. So from my understanding, 3GPP is made up of 7 different organizational partners, and ETSI is just one of 7. So what? Did they ask all 7 and get permission from all 7 of 3GPP organizational partners to publish their derivative work under the Apache license? I don't know. I wasn't there. And all of this work was done in the Android ecosystem. So I don't know if maybe Google threw their weight behind it. I'm just speculating at this point. I don't know. But the end result was the work was done in the Android ecosystem, and then came some fellow who took the code from the Android universe and ported it to classic Unix Linux environment. And that's how we got open core AMR and B. That's the genealogy of that library. So, I mean, if they were able to obtain permission from not only ETSI, but also ETSI plus the other 6, would it be possible for someone to similarly obtain permission from ETSI to redistribute the older codecs, the one I care about? I don't know. Not my world. Not anything I have any knowledge of, but just putting that out there. So let's see. Where do we go? Again, this slide I won't get into too much detail. So the first paragraph, you really got to read the whole paragraph here, because a lot of people say INL, but I take it a step further. So this, is kind of like my ultimate logical extension of the INL concept. Uh, but then the rest of the slide, you can see from an end user. I mean, you can still download the code. You can still download the code from my site. You can compile it locally, and you can locally integrate it, with SMACOM, using, any of the interface points, like whether the interface is MNCC or in the future the AVIP interface. That's a well-defined interface between SMACOM components and Themyscira components. So if you download Themyscira components directly from my site, compile them from source, run them on the same server machine alongside SMACOM, you can do it, right? Again, INL. But that's kind of how it is. But yeah, I still take pride in my accomplishment, because even if it doesn't meet all the legalities of FLOSS, to the best of my knowledge, nobody has done this before. Nobody in FLOSS, or even not quite legal FLOSS like published source software community, nobody has done this. Nobody has produced, a published source, mostly FLOSS-based network that replicates the quality of, say, T-Mobile USA or Telcel Mexico when it comes to how well it does the transcoding function. So I still take pride in my accomplishment here. So let's see where we go. Yeah, and this is a recent development. A big thank you to Harold for getting my patches. CR+2 didn't get it and ultimately merged. So now there is support in mainline SMACOM in the entire BSS and the base station subsystem to generate these extended RTP payloads. So a little bit of background. It looks like we have time, so I can cover a little bit of the background behind this. Why was this needed in the first place? So when 3GPP developed specs, well, it wasn't even 3GPP, because what happened was 3GPP dragged their feet. So for a very long time, 3GPP did not provide any specs whatsoever for GSM over IP implementation. So not for A interface, not for ABS. I mean, still to this day, there is no 3GPP spec for ABS. They do have a 3GPP spec for A over IP, but that spec came late. And then 3GPP dragged their feet so long on that effort that people in the industry couldn't wait, and they came up with their own ad hoc solutions way before. I mean, I'm sure everybody here knows SCCP Lite, IP access, all of that world. So that's a prime example of the industry not being willing to wait for 3GPP and just taking matters into their own hands. So when 3GPP finally did get around to standardizing A over IP, and I mean, they did innovate a little bit on the control plane and the BSS map. They added some new IEs, but on the user plane, that's the really critical part. On the user plane of GSM transport over IP, the only thing that 3GPP did was codify already existing industry practice. And that industry practice is, in my opinion, crap. Sorry, it's kind of shouldn't be using that kind of word, but there really isn't a better term to call it, because it is a severe regression compared to how it was in TDM world. Because in the world of TDM, everything was very neat and clean. So if you look at the ABIS over E1, the interface between the E1-based BTS and the BSC, you have all these metadata flags. So every time you have a frame coming on the uplink from the BTS up to the BSC, and ultimately to the trough, in that frame, you have the payload bits, and you have the metadata bits. You have the BFI flag, you have the seed classification bits, you have timing alignment flag. And all of that was stripped out with the industry standard RTP payload formats, because the RTP payload formats of RFC 3551 and all that entire world, that was not invented with GSM in mind. The people who invented that, they were not software-defined GSM people. They were people in either VoIP effort or this Typhon. There was this other thing like G323, sorry, not G, H.T23 world. It's a completely different universe compared to GSM. So the payload formats that they invented, they may be great for their application, but trying to use them for software-defined GSM implementation, for GSM ran over IP, they suck. They introduce a horrible regression compared to classic GSM 08.60 trial frame format. So what did I do? I invented my own. I invented my own extended or enhanced RTP payload formats. And now, thanks to Harold and thanks to everybody else who gave their positive code review votes on those Gerrit patches, it is now supported in OsmoCom BSS, both in the BTS and the BSC. So the way it works is there is a new information element that can be added to BSS map assignment request. So from the core network side, you send the assignment request to the base station subsystem, and you include this non-standard information element that says, I want these RTP extensions. Osmo BSC decodes this information element, keeps track of it in its internal state, and passes that onward to Osmo BTS in another extension, i.e., this time on AVIS RSL. And then Osmo BTS starts emitting RTP packets in this extended format that has these metadata bits. And so what's the practical benefit of this? Well, one is TFO. This thing right here, GSM 08.62 TFO, that's a fascinating topic on itself. I will be doing another presentation in the future on that topic where we'll go into full depth of what that is. But basically, TWTS01 is a prerequisite for doing it correctly. So now the prerequisite has been met. And also with my libraries, the libraries that I have for both the FR and EFR, these libraries will perform better, fully to the spec when we have these extra metadata bits. So that's the benefit of having this. Now the shortcoming is that with mainline OsmoCom, you can't really do it. You need a mixture of mainline OsmoCom plus some non-mainline components to generate this extent. And so we'll have a discussion, I believe, once in the next slide, there'll be a discussion slide, is thoughts from OsmoCom community. So if anyone else here besides me is interested in this feature, if someone wants to play with this capability, this TWTS stuff, but you want to do it without the Mosquito components, if you want to do it in more of a pure OsmoCom environment, then the question is, well, how would you envision it being represented in this world, in this MNCC SDP world, which I've kind of opted out of so far? And let's see. And that takes us, this is our last slide, and this is all a discussion slide. So, end of lecture, beginning of discussion.
Yeah, well, first of all, thanks for the presentation. I'll see if somebody else wants to bring up some topics first. Okay, since nobody speaks up, then I think putting media handling inside the Osmo MSC process is not a good idea, if not only for ease of debugging. I still remember this from the old days of the Osmo NITB, where we had the same. It's very nice if you can S-trace or do some kind of debugging on a signaling process, and you don't get the noise of all the traffic channel data.
I'm sorry, that misunderstanding. I never proposed changing this. So in all of my proposals, the separation between control and user planes fully remains. So where did I give the misleading impression that I was doing away with it?
Okay, there was this diagram. Maybe I misunderstood you then, where you said,
well, this is just a STR block diagram. So let's go back to that. So this block diagram here, this block diagram does not show the control plane, just for brevity, because, STR diagrams are kind of a pain to draw. I omitted the control plane. I'm only showing the user plane here.
Okay. Yeah, never mind then. Then forget about the comments. Sorry for that. Then regarding the adding transcoding to Osmo MGW, it's something that we always had in mind, and actually a very early version or predecessor of Osmo MGW did support some form of transcoding using a transcoder hardware that was at that time used DSP cards. So I think it's definitely in line with sort of the roadmap of where we think it's going. or should be going if it goes anywhere. So I don't see any opposition from our side of doing that. Then there was the topic that you said, well, 3G is not relevant to you. For the license reasons, I understand and appreciate that. But in general, I think there is retro networking interest in 3G because 3G is switched off in many places already. And there are people who want to operate 3G phones, just like the collectors and so on. So I just wanted to add that as a comment. I mean, it's not relevant to you, yes, I understand, but in general, I think actually there will be quite a bit of interest in the 3G support of Osmocom. And so it might be wise not to sort of close any bridges there in whatever work you're doing.
Well, I appreciate this comment. Yeah, I definitely appreciate as far as the retro networking interest in 3G. I am aware of some. I mean, even in today's vintage mobile phone community, like on Reddit and whatnot, I do occasionally run across people. Their use case goes something like this. They will take a phone, say it's a slightly older smartphone that's new enough to be a smartphone, new enough to have 3G and data hungry applications that depend on 3G plus like HSPA and all this stuff, but still old enough to not support LTE and like this middle ground. And I tell people, well, why don't you just run it in 2G mode? They all support 2G, but then the response is, well, yeah, but I want to play with all of its fancy data hungry features that really want 3G and HSPA. So you might be referring to the same type of sentiment, I'm guessing.
Yeah, or for example, stuff like 3G feature phones that were not smartphones yet, but that support video calls, for example, right? That you can't do it over 2G. Circuit switched video calls, certainly you can't do.
Circuit switched video calls. Well, yeah, I didn't realize they were circuit switched. I didn't know how that worked. So you can actually do circuit switched video calls in 3G. I didn't know that.
Yes, it was very popular in South Korea for some time. I'm not sure how popular it was in other regions. It was very expensive here in Germany, so nobody used it. Almost nobody used it. But the way it works is that it creates a 64 kilobit UDI bearer, basically over a circuit switched 3G, and then you have something that I didn't really investigate. I suppose it's some H.26 something. So basically the usual stuff that you also have with ISDN video calls, given that it's 64K.
So you can do a video call in just 64K. I mean, it seems like so little bandwidth for video.
Well, but it's the same in circuit switched ISDN networks. You can do video calls with 64K. It's an established concept. So, but yeah, anyway, I don't want to distract. I'm just saying that there are people interested in that. So, but regarding the codec licenses, I agree that in general the best approach is to, of course, not distribute such code or include it or require it by default, but have some kind of plugin interface. And then if a user at their own risk wants to download the code from Etsy and apply patches and build it, then that can be done. This is a well-established practice for audio and video codecs for quite many years, not just in the cellular area. It's perfectly legal that you distribute, let's say, patches against some reference code, and the script that will download the original code from Etsy and apply patches and build it, as long as you don't distribute all of it together.
Oh, yeah. I mean, I've seen this approach. I'm wondering, as another approach. Let's say you people in the community like me who feel otherwise. So let's say it's not Osmocom. It's me through my own freecalypso.org domain name, my own servers. I distribute my Themyscira libraries, which have been done in the manner in which they've been done. And let's say there was a patch in Osmocom that would introduce an optional dependency, optionally add like a with my libs or something that would allow linking with those libraries. How would you feel about that?
We would have to look at the details. In general, I think it's maybe smarter to, particularly for stuff for codecs, where the amount of, let's say, API is very limited, to have some kind of plugin-based interface, like we also have for for example, for the encryption algorithms for GPRS. OsmoCore has a plugin interface for that. So you can build a normal OsmoCore, and well, at least traditionally, I think this has changed now, but at least traditionally, it only supported GR3 because that was the only algorithm that was publicly available before GR1 was cracked and published. But with, like, at the time when GR1 was not publicly known, those people who had an implementation of it could basically just throw the plugin in the right directory and it would work.
Okay, so I wonder how would this plugin mechanism work? I have a difficult because I'm not familiar with that one. I've seen, like, for the ECU framework, you do a similar thing. You made like a license exception, but from an operational point of view, so you've got OsmoCom libraries, you got libosmocore and other libraries, then you got OsmoCom applications like OsmoMGW and others. So you have an Osmo something process, the server process that depends on the libraries. So you got this complete stack. How would you introduce the plugin into this stack? I don't quite understand that.
Well, let's say you have some generic, you come up with some API that is used for codecs. Maybe, I mean, of course, I understand it's not as easy as just putting frames in one format and pulling it out. There's other stuff that needs to be handled. But let's assume we come up with the grand unified theory. These are the 10 API calls that we can use for any kind of codec that we encounter in our domain. Then we can have a function by which a plugin can basically register itself as an implementation of this codec. Well, I implement the EFR codec, and this is my structure with all the functions. And then you basically, when you start the program, you look in a certain directory and you match some file names and you DL open all of them. And when you DL open them, basically the linker will register those with the callback core.
Okay, so basically the framework would have to include not only because I understand the part about the registration functions. I've already seen that in OsmoCom libraries. The part that I'm most questioning about is like the whole directory search. So I'm not aware of there being any infrastructure for it. So like somewhere in VTY, you would indicate that this is directory path to look for plugins. There would be a function somewhere that searches through directory and calls the DL open. Do we have anything like that?
It's a long time since I looked at it, but let's say, let me check. Yeah, we have actually a plugin.c file in libosmocore that will actually go through. Well, you pass it a directory name, it will go through all the files there and try to DL open it. And yeah. So anyway, we don't need to go into the details, but there is already some code for it, and if we need more, we can certainly add more for that.
Okay, so that's a possibility then. Yeah. Okay. Well,
it's a clean possibility. It doesn't, like, we don't need any build time dependencies. You can use the normal, even let's say a precompiled official OsmoCom package for those users who are not really up to building everything themselves. And they just can throw a plugin in a directory and it will work. I think that's from a usability point of view, that's the ideal situation. And we don't have a license problem either.
Yeah, that might be a good way to do it. Yeah, that's certainly a thought. Okay, so basically that was the main obstacle in my mind for transcoding in OsmoMGW. I was thinking, okay, well, yeah, it seems like there may be support for transcoding, but what about the libraries? Yeah, but that might be the way to do it.
Yeah, and it's regarding EFR. My question is, how much EFR, like how much things do we need that are that regarding EFR that don't exist yet, given that EFR is the same as one of the AMR modes, and there is this Google AMR library.
But it isn't the same. This is the one that I wrote entire treatises on. So if you look in any of my code repositories related to this stuff, I wrote some pretty long essays explaining all of this stuff. but it mostly, well, I mean, if you don't care so much about the fancy features like the homing, obviously the homing frames are different, but the biggest one is the difference for DTX. So if you want to have DTX in the uplink, if you enable DTXU in OsmoBSC config, then anytime the user is listening and not talking, what will happen is the mobile will transmit seed frames that are they're going to be EFR seed frames, and they will be transmitted at time positions defined by the multiplex matching the such multiframe. So there will be the time alignment flag of TWTS001. And then the codec library has to be able to handle this. So the codec library will receive it will receive a stream of frames. It will have speech frames, it will have seed frames, and it will have BFI frame gaps. And it has to decode, including the comfort noise generation. So and the comfort noise is bit exact for EFR. There's a spec, I think it's 06.62, which gives a bit exact definition of the comfort noise generator. And of course, the official code from Etsy, it's all integrated. In the official code from Etsy, there is no separation. It's so tightly intertwined. So the function of comfort noise generation, it's not a separate front end that you can just separate. It drills deep into the guts of the codec. So that's the difference from FR1, because in FR1 it's sort of like a bolt-on piece, but not in EFR. It goes deep.
Yeah, okay. Well, I was just wondering. So, I mean, in the worst case, we can do the Etsy reference codec approach, like for half rate with the plugin that gets put somewhere. For AMR, we can use the existing library and modify it if needed, the open core AMR, and export the symbols or whatever. I mean, there's no restriction on since it's under an Apache license, we can do whatever we want and have our own fork or something of it and link against that bit, right?
Yeah. So for AMR, doing a fork of OpenCore AMR NB with slightly improved API, improving the API, making it more 3GPP like. Yeah, and then for FR1, can use the Themyscira library, which is my own original work, so no license issues.
So yeah, it's really HR for sure where we need this approach, and for EFR, as you mentioned, apparently also.
The same. Yeah. I'm also waiting, kind of like a tangential subject. I'm getting a lot closer to bringing the Nokia Trao up and running. Still not quite there yet, but once I get Nokia Trao up and running by behavioral reverse engineering, I want to see how it does the functionality of what is the spec TS28062 section C.3.2.1.1, this elusive mystery. Once I learn experimentally how the Trao does that, I'm going to see about adding that functionality to the libraries, making that also available. But yeah, I kind of wonder how. So I guess we discussed, these topics. Yeah, I still find it a little bit bewildering. How come no one else has really had to face this issue so strongly and so head on? So other people, I guess, have been lucky that they've been able to just dodge the issue. I know, but I watched the whole presentation by AMN, and it seems like their approach is they just hook up, that they had existing operators who allow them to hook up to their core network. Oh, great. Yeah. If an existing operator just allows you to hook up to the existing CN, you have to worry about any of this. But if you don't have that luxury, you have to build your own CN, well, then, yeah.
Yeah, but I mean, in terms of professional users of the OsmoCom stack, I would say for 95% at least that's true. So you have an existing core network and you just add the radio access network to it.
Oh, okay. Well, that was a figure I didn't know. So you just gave me this 95% figure, which is not just AMN, but apparently across the board, most of them are able to just, they build their own RAN and plug into an existing CN. So in other words, the OsmoCom CN component, Osmo MSC in particular, and everything that goes with it, you're saying that's only used by 5% or less of professional users?
I would assume. I mean, of course, I don't have a full picture, as you know. A user doesn't need to tell us that they're using it. But that's sort of my impression. Yes, and it's also easy to how can I say, it makes sense because I mean, who is operating a cellular network or a GSM network? It's people who have licenses, and you have like we were late, so we were 20 plus years late in terms of GSM deployments. So. Most people who use the code are already existing operators, which means they have existing core network equipment, and they just add the radio access side to it. And those people who are not existing operators are mostly lab or research entities, and they then run the full stack, but they are only running in a lab, and probably all the accuracy of all the codecs and interoperability with ancient phones is not really their main concern.
Yeah, because so basically, it seems to me Rhizomatica is the only other entity besides me who actually operate a full end-to-end network in production. But the difference is they are in a different numbered world, and they have different concerns. Probably don't care so much about.
I think there are some more, but they are not public about it.
Yeah. Okay. Yeah.